Welcome everyone once again in robust study. As I have promised with you, once again I'm back. This time with the another revision chapter, light, reflection and refraction. Okay, so इस बार हम reflection and refraction chapter को discuss करेंगे. Okay, now the focus only on the the important points, though we will cover everything which is important for the exam. Fine. Okay, so what is reflection and what is refraction, and these are the two very important phenomena. These are very two important phenomena. So this phenomena basically we going to have it here. Okay, so what is light? So as book says, it is the form of energy. Light is the form of energy, and light travels with 3 into 10 to the power 10 meter per second. Okay, this is the velocity or the speed of light in air and vacuum. And there is a two sources of light. One source is self-luminous and other is non-luminous. Okay, so self-luminous and non-luminous. Okay, now the next very important, rest is straight in the straight path. Fine. So I hope this is very clear to you guys. Okay, now the main thing starts. We will discuss now. What is that? What is the reflection of light? So what is reflection of light? So reflection of light is the phenomena, okay, bouncing back of the light in the same medium. So medium in the will be same in case of reflection of light. Okay, so the medium is same in case of, so once light responds back, bounce back, okay, then it is called reflection of light. So let's take an example. I can मान लीजिए this is a mirror. So in mirror, and this is a normal. Okay, so when the light bounce, when the light incident on a mirror, it's bounce back. Okay, it's bounce back. So this is called, is bounce back in the same medium. So this is air, this is glass. Okay, this medium is glass, this is glass. So after striking the light ray on glass, it's again bounce back. Okay, so this is called reflection. And we have two laws. Okay, now we will discuss what is this. This is called incident ray, incident ray. Okay, and after the striking back, when it's bounced back, the ray which is reflected is called reflected ray. Okay, and this is called normal. This is also called normal. That's great. Fine. Okay, so now the next important point is what is the laws of reflection. Laws of reflection. So there is a two law of basically followed by the ray of light when it's strike to any reflecting surface. So these are the reflecting surface like mirror. Later we will discuss about the lenses and all, you know already. Okay, so I assume this session I'm taking with the assumption that I know, like you know already concept. We are discussing, we again rephrasing, revising the concept. So they say now what is this? This is called incident ray, this is reflected ray, and the normal. So the first law of reflection say the incident ray, the reflected ray and the normal, all they lies in the same plane. So this is the plane. Okay, so all lies, they are this is the first, so all lies in same plane. Okay, plane. Fine. Okay, now the next important thing, so what I said, this is normal. Okay, so the incident ray makes an angle with normal, this is called I. So angle I is an incident angle, or we call angle of incident, angle of incident. Okay, and when the reflected ray makes an angle, okay, with the normal, which call angle of reflection. Okay, and the second law say ki, what did say, it said the angle of reflection is always equal to angle of reflection. So I'm really sorry, the drawing is, this is not equal, but in the ideal condition angle I is equal to angle R, means angle of reflection is always equal to angle of incident. Okay, fine. Okay, and for normal incident, okay, so what happened for the normal incident, so this is the second law. Okay, and so when it is the normal incident, okay, the traces back, so let's talk about the normal incident. What, so normal incident means, suppose this is the reflecting surface, right, and the this is the normal, and the same in the normal only, the light falls, okay, the rays of light incident normally, okay, means it is perpendicular, it is 90 degree, so it traces back. So this is normal, this is normal. So and the light is normally incident on the normal, means reflected ray, incident ray and refracted ray, they all fall and bounce back into the from the normal only. Okay, and what happened, so since all three are into the same plane in the same line, so angle R, angle of reflection incident, would be 0, and R will be also 0, because it is passing through the same is tracing back to the same path. Okay, so in case of normal, angle I is equal to angle R is equal to 0 degree. So there might be a question in exam when they will ask, what they will ask, they will ask what is angle of incident and angle of reflection. It is 90 degree, it is 120 degree, it is 360 degree, or the 0 degree. So the answer would be 0 degree. Fine. Okay, so now I hope this is clear. Okay, let's move to the next point. Now next point is how this is a very important part, characteristics of the image formed by the plane mirror. Okay, so the how the what are the characteristics. So the first characteristic is the real object is always virtual. Okay, in the image of the real object, so what the is always virtual. Okay, and it cannot be taken on. There's a lot of questions they ask, can it be taken? No, it cannot be taken. Okay, so the image of the real object is also virtual in case of plane mirror. Second, the image formed in the plane mirror is always erect. So first point is always virtual and cannot taken into the screen. The second point is always erect, and upside of the image is upside of the object and vice versa. So if you stand in front of mirror, the way you have stand, you exactly looks like the same. So this is the mirror, you stand up in front of the mirror, okay, and you exactly the way you looks like it is, that's what you say, upside the mirror is upside the object and vice versa. Fine. Third point says the image is always same, so your height doesn't change, the height remains same. Okay, and the image, the very important point, the form, the plane image is far behind the mirror. The image formed in the plane mirror is far behind the mirror. So if you are 3 feet away or 3 meter away from the mirror, your image is formed 3 meter away from the mirror. So that is the saying, the image formed in the plane mirror is as far behind the mirror. Okay, that is the reason the total length, the distance of the image from you is basically 6 feet, is 3 feet plus 3 feet is equal to 6 feet. Fine. So I hope this is clear. Now we have seen through reflection, and we have seen through what? We have seen through the characteristic of the plane mirror. Now let's talk about the spherical mirror. Now spherical mirror. So what is the spherical mirror? So suppose there is a globe. is a hollow. I would not say it is globe. It is the hollow glass. Okay, nothing is there. It's empty. And if you cut the glass vertically, and the if you polish from one side, so the other side it will convert it to into mirror. So this will be the reflecting surface in this case, and this case this will be reflecting because you have polished. Okay, fine, that's very very good. Okay, so the spherical mirror is whose reflecting surface is the part of the hollow. So how we have formed this mirror? We have formed this mirror by cutting vertically. Okay, by cutting vertically a hollow sphere. So when we cut a hollow sphere in concave mirror, something like this. Okay, so we found if I take away this particular part, it will be formed, and will when I polish this surface, okay, so it will be like a concave mirror. And uh, when I polish the other side of the subject, then it will be the convex mirror. Okay, so that's what it's towards the center of the sphere, which is the major part of it. Fine. Now we will discuss few very very important concept. Okay, so which is very very important. Okay, to remember, and lot of questions they come ask. So this important, the center of curvature. What is center of curvature? Okay, so center, suppose I have taken uh, a two hollow sphere. Okay, and I cut them vertically like this. Okay, now the straight line which is dividing sphere, let me polish this surface in order to make them concave or convex. Okay, so this is concave and convex, so this one become convex, the B1. Okay, and A is your concave. Fine. Now here I will discuss, this is the center of the hollow sphere, it is the center of the hollow sphere. Fine. So what is the center of curvature? Okay, the center of curvature spherical means the center of the hollow. So this hollow points, these are called, if you suppose this O and O dash, so O and O dash are the center of the hollow sphere. Okay, so they are the basically center of curvature, and normally it is denoted by C. Okay, now what is pole? So pole of the is the center of the mirror. So which will be the center of the mirror? So this will be the center of mirror. So these are poles. Fine guys. Okay, now third one is the radius of curvature. So radius of curvature is the of the spherical mirror is the radius of the hollow sphere. So what will be the radius of the hollow sphere? So there's a distance from pole to center of curvature. This is basically radius of, so if I P and C, so PC is your radius of curvature. It is represented by R. Here also P, or I can say PO. Oh, or here you put PO dash is equal to R. Fine. I hope this is clear. Now what is principal axis? The straight line passing through the center of curvature and pole. So this is the straight line which is passing through center of curvature and pole is called principal axis. So this is principal axis. Okay, and this is basically, and the both the side, it's basically produced on the both the side. So if you take this side is also there and this side also there. Okay, now aperture. The aperture of the spherical mirror is the diameter of the reflecting surface. So it is the nothing but is the diameter of the reflecting surface. So suppose if I, this is M dash and this is M, so M dash is nothing but is the aperture of the reflecting spherical mirror. Now one very very important, so you have understood it. So center, this is called center of curvature, this is pole, this is aperture, and this is all radius of curvature. Okay, now very important thing, we have to understand this one, the principal focus and the focal length. So what is principal focus and focal length? Okay, so here I have put it this a combined definition. Okay, so is a point of the where all the rays parallel to the principal axis actually meets or appear to meet. So here's the 2 point. Okay, so I'll take you the example of concave and concave mirror. Let me explain you. So when, as I explained you already, this is principal axis. Okay, this is your pole and this is your center of curvature. Okay, and this is your focal point. Okay, okay, this is your F. Now what happened when the all the rays, when they fall to the mirror, after reflection it passes through the principal focus, and this is called, this is, and similarly if I take it from this side, all are passing through one particular point, and this point is basically, so if you see all the rays after which is parallel to principal axis, after starting meeting at a point, or in case of convex mirror, okay, in case of convex mirror, what happened in case of convex mirror, sorry, in case of convex mirror, in case of convex mirror, they are basically, they after the striking, what they do, they basically, the picture is not very neat, but I'm just trying to make you understand how it look like. Okay, so they appears to meet. Okay, so basically after reflection they appears to meet. So here they meet and there appears to meet. I'll just put it down with 2 ray, so it will be more clear. So since it is, this is the reflecting surface, it won't go further, but if you extend this line, so this is incident ray, this is incident ray, if you extend that line, so they will meet here. These are the focal points. So these are the focus, principal focus for a convex mirror, and this is the principal focus. So the definition is, after when the parallel, this is the principal axis and these rays are parallel. Okay, so the rays which is parallel to principal axis, after reflection either they meet or they appears to meet, are called, are called, R is the point where they meet is called principal focus. Okay, now this is, I think this is very important. Now some Cartesian product, this is very Cartesian sign, which is very important for your numerical, and I hope you have understood it. Okay, so here what is all the distance measured from the pole, how the distance are measured. So distance are measured in the spherical mirror from the pole. So if I take this diagram, okay, so again I say this is principal axis, this is pole, okay, this is center of uh, curvature, this is focal point. Okay, now all the distance are measured from the pole. So from pole we measure distance. Okay, the distance measuring the direction of incident of this. So ray, direction of incident ray is always this side, if you remember, this is this side. So incident ray direction. Okay, so in this direction whatever things has come, we take it positively, and if it is away it is taking as a negative. If it is other side the direction, it is taking as a negative. So vice versa. the height above the principal axis of the mirror are taken positive. So now object is standing here. Okay, so this object is standing here. We call it as a what? We call it as a this is what? This is your object, and object is always taken positive. Similarly, the image is formed below, so the image is always taken negative. Okay, and the very important thing in the spherical mirror, what is there? The focal length is the half of the radius of the curvature. So if you take a mirror, so this is center of curvature. Okay, okay. So if you remember what I have told you, okay, so what is radius of curvature? It is the radius is the sphere glass, is the radius of the sphere glass. So what is the radius? So here from the radius it will be your radius of curvature will be, okay, pole. So this is center of the curvature, sorry, this is R. Okay, so f would be, focal length would be r is equal to f is equal to r by 2. So the focal length would be flowing somewhere here. After, as I said, we discuss. Okay, so this will be focal length, but it will be what? It will be half of the radius. So f is equal to focal length and r is equal to radius of curvature. Okay, fine. Okay, now we have done very last of important thing we have done. Now the later one, now like we are coming to some difficult portion of the chapter. Okay, now difficult chapter portion of the chapter is what? The ray of light. So there is some rules uh, the rays follow, okay, while making a tracing a image forming an image in the concave mirror. So first one, a ray of light falling on the concave mirror in the direction parallel to principal axis passes through the principal axis, or passing through the principal focus. So suppose what it says, suppose this is our a concave mirror. Okay, so this is our principal axis, this is our center of curvature, this is our focus. So the rays which is parallel to the principal, this is principal axis, so after reflection it will pass through the focus point. Okay, it will pass through the principal focus. So first one, so if we say the parallel which is passed through the, second say the rays of the light falling on the concave passing through the center of curvature reflected bit. But if this is the concave mirror, this is the first condition. Okay, second condition is said if this is the center of curvature, okay, curvature, and this is focal length. So if the rays fall in the center of curvature is traced back, it is the condition same as in the plane mirror. It is the normal incident of ray. It is now here is from center of curvature. If you say this is what, this is I, this is R. Okay, okay, angle I, angle R. So here angle I and angle R is not formed. Here angle I is equal to angle R is equal to 0 degree. Fine. Okay, now the third point, the ray of light passing through the focus of the, now the third one is just reverse of. Here I say what it says in the first case, if it is parallel to principal axis, after the reflection it will pass through the principal axis. But here what I'll say, if it is passing through the focus. Suppose this is center focus, the center of curvature. So suppose if it is passing through focus, so what will happen after the reflection? It will be the parallel to the principal focus. Okay, if this is the concave mirror. Okay, so here when it is parallel, it will passing through the principal focus, but when it is passing through the principal focus, after the reflection, it will be parallel to the principal focus. Okay, now we have done. Now the next important point which is there, the summary, will not discuss the part. So the summary we will discuss one by one. Okay, so what happened, the how the what is the characteristics of the image formed by the concave mirror. Okay, so the characteristics are such, like if the position of the object is at infinity. Okay, so if I say, you have to remember this concept. Okay, by heart it, the position of the image will be at the focus. Okay, and it will be highly reduced. Okay, so suppose this is the picture. So if the image is coming from the incident, okay, and this is our center of curvature, I'll extend it a little bit bigger. So this is our focal. Okay, so it will be forming like this. Okay, so this supposed to be parallel. Okay, it's supposed to be parallel. It's not very neat. So if you say this is image is formed and this is the concave mirror. Okay, so in this case, what is that? So if it is the incident, the image will be formed. So if it is infinitive, image will be formed here. This is the image in the case 1. Okay, now case 2 says, in case when it is beyond C. Now this is C, this is F. If it is beyond C, somewhere here, so the after, if this is a parallel, so it will go to the, it will pass through the center of focus. Second, it is passing through, suppose I'll alter, if it is passing through, okay, it is passing through, this is object, this is, so it will be passing through the center of curvature. Suppose this is the center of curvature, this is the center of curvature, so this will be the image. So image will be between the C and F. Now when it will be passing through center of curvature, okay, when the object is there, the center of curvature, okay, is the center of curvature, center of curvature. So if it is like this, it is center of curvature. Okay, the third condition, if you say, okay, and this is the focal length, so after deflection it will forming the center of curvature, it will pass through the focal length, and after the, once it is passing through the focal length, it will be the parallel to the principal of focus, and they all meet here, so the image will form here. This is the third case. Okay, similarly between C and F, it is beyond C. Okay, so in the third case, in the fourth case, this is the case 2, this is case 3, and the third case, say if it is at focus. Okay, so this is, suppose, our convex mirror. Okay, and if it is, this is center of curvature, this is focus, so one ray from here it will trace back, I know, we know that as per the rules, and the other ray, when it passes through, it will is parallel to the principal axis. Okay, so it will be coming from this one, and they will meet somewhere here. So it will meet here, which is highly, which is meet. Okay, at focus, you know, and when they lies between, okay, this is the fourth one, okay, that is the, it will be beyond C. Okay, fine. Okay, now similarly when it is the focus, it is infinitive, which is highly enlarged. Now you have to remember all the size of the image and size of them, and when it is, and this is the fifth one. Suppose this is very rough drawing, so you please follow your book in case of you want it the exact design. Okay, and otherwise I will post it. Okay, so it will be infinity, it will never meet like the way it met here, it won't meet here, it won't meet here. Okay, this is the fourth case, this is fifth case, and the last one it will always meet. So center of curvature is here, this is focal length. Okay, so it will trace back same, which is passing through curvature. The second one is basically focus. Okay, and it will be, and when you extend this to it will form here. So it will, so it said is behind the mirror. Okay, so for exactly neat picture, this is to just to revise you, I made some graphics for you, but please follow your NCRT or any reference book whichever you are using. Okay, that way a lot of books are very good. Pradeep is very good book. Okay, so use that one. Now in convex mirror, only two conditions: at the infinitive, at the focus it is highly diminished, and it is either between the infinity and pole, is behind P and F, and it is highly diminished. Its diminished is the one is highly diminished. I hope this will be clear. Now the another very important point is the lens formula. Okay, let's come back to what is the mirror formula. Sorry, no, not less formula. So it is the relation between the object distance, image distance, and the focal length. Okay, so what is the image distance? Suppose image distance, object distance is u, image distance is v, and focal length is f. Then I say 1 by object distance plus 1 by image distance is equal to 1 by focal length. Okay, so if I say u, v, and f, if I write in this term, then 1 by u plus 1 by v is equal to 1 by f. Okay, and as I know f is equal to r by 2, so I can say 1 by u plus 1 by v is equal to 1 by f, and or I can say 1 by f is equal to 1 by r by 2, so I can say 1 by v plus 1 by u plus 1 by v plus 1 by f is equal to, this is r by 2, this is 2 by r. Fine. Okay, so the mirror formula can be so this will be this one. Okay, so 1 by u plus can be written as 1 by v plus 1 by f is equal to 2 by r. Fine, I hope, and this is very important, and you should I hope you have understood the Cartesian sign convention in order to say whether it is positive, negative, or what. Now next important topic is your linear magnification. The linear, I mean, how the image will be magnified, how bigger it will look like. Okay, so it will be produced by the it is depending on the height of the image to the height of the object. So we said linear, we said, let me put it down, linear magnification is what? Is equal to, denoted by m, is equal to, it is the ratio of, height of image upon height of object. Okay, so if height of image is h2, if it is s2 and this is h1, so this is s2 by h1, or I can say m is equal to s2 by h1. Now that is the definition of measure. So lot of objectives, a lot of numerical will become. Now what happened when the size of image is greater than size of object? Okay, means h2 will be greater than h1. So m is equal to h2 is h1. Okay, so means m will be positive. Okay, and when size of the image, when h2 is equal to h1, when they are equal, so m will be 1. So any numerical value you take, if it is m is equal to 4 by 4, so both are equal, is equal to 1, so that's why it says 1. Okay, now next point is when the image is the enlarged. Okay, when the h2 is smaller than h1. Okay, h2 is bigger than h1. So what will happen in this case? M will be negative. Okay. Okay. Now the other condition is when it is plus, minus, and what will happen when for the concave mirror m is positive and less than 1, then the image's form is virtual, erect. So you have to remember, in the convex mirror, when m is positive, or I would not say it is less than 1. Okay, then the image which will form is the virtual image. Okay, and in case of concave mirror, it will be the image is formed real, and m may equal 1 or less than 1. Okay, it will be a size will be depend upon the height, as we discussed h1 and h2. Now the last point on the reflection side, last 2 points rather. So what are the use of the, normally a lot of question they ask, what is the use of concave and convex mirror? So convex mirror is used for as a rear view. Okay, in your automobile's car. It is also used as a street lamp. Okay, because street lamp, it will use as a reflector. Okay, concave is used as a headlight of the motor. So don't get confused with the rear view glass and the headlight. Okay, both are used in the motor vehicle. Telescope it's used also used in the, because it works as a converser. Okay, is also used in some dentists, they use, ENT doctors they use also. Okay, so that is the one part, and the last, we have reached to the last part of this portion. So this portion, how can we distinguish that? Now the question asked in theory or in the long question, how do we distinguish plane mirror, concave and convex? So we distinguish without touching them. So if you don't, the condition, you don't have to touch them, but still you have to tell which is plane mirror, which is concave, and which is convex. Okay, so if all three images are virtual, erect, but image in the plane mirror are of same size, image in the convex is diminished, and image in the concave is the magnified. So here 3 points you have to remember. For case of the plane mirror is the same size. In convex is diminished, and concave is magnified. So if you go in front of them, and then if you find these three differentiation, then you will completely say which is concave, which is convex, and which is a plane mirror. I hope I able to confine entire portion into 30-40 minutes time period. But it is a big chapter, as I said. So very soon I will cover the light of reflection part in my next streaming. Stay tuned, okay, and keep watching. Thank you very much, huh? And subscribe us, motivate me so I can bring a lot of videos also. I'm also bringing videos for the completely Hindi medium students to also help them in further revision.